It's not just radio, it's Rockland World Radio. RocklandWorldRadio.com.
Welcome to Dialogues with Dan, heard on Rockland World Radio every Tuesday evening at 6:30 p.m. Eastern Standard Time. Be sure to check out the archives of past programs, and be sure to hit us up in the chat room located off the menu bar. Now, the host of Dialogues with Dan, Mr. Dan Windheim.
Thanks, Richard. Hi, everyone. This is Dan. As I like to say, we've got a live guest. And when I say a live one, it really ties into tonight's show. Tonight, I'm speaking with Nick Morphing from Rockland County, New York. I'd like to introduce Nick. Hi, Nick.
Hi, Dan.
How are you?
I'm good. Thanks for having me.
Oh, sure thing. Yes, Nick. Maybe. Well, I know you're a project engineer. Maybe you could go more into depth about your job and your company.
Yeah, sure, Dan. So I'm an engineer at Stryker. The company is based out of Michigan, but I work in the orthopedics division specifically. We're based in Mahwah, New Jersey, and we make orthopedic devices for joint replacements, but also for trauma fracture fixation. So that's my specialty. That's really where I spend the most of my day, is in trauma, to develop instruments and implants for the fixation of bone fractures throughout the body and also in the skull.
Yes, which they must be very important when you break a bone or crack a skull. Maybe you could start by giving us some examples of the medical implants you have brought in.
Yeah, sure. So I brought in some of the main methods for treating trauma fractures. There's really three main ways to treat trauma, and one is with a plate. And so a plate usually can be straight or it can be bent so that it fits onto the bone. And then a plate is fixed to the bone with screws, and then the bone can be held in place with the plate and the screws until it can actually heal. And like I said, that goes on the outside of the bone. So the surgeons will open the patient, put the plate in, put the screws through the plate and into the bone. Another more common way of treating fractures is called a nail. And a nail is really just a long tube or a rod that's inserted through a bone. So it's actually placed inside of a long bone, such as the humerus in the arm or the femur in the leg or the tibia, or even the foot now. We have nails like this that go into the foot. And the way these nails work, like I said, is they're actually hammered down the length of the bone, and then they're fixed within the bone using screws, which go through these holes in this oval slot here on both sides of the nail and hold it in place and hold the bone in place so that the fragments can actually heal effectively.
Yes. Would you have any idea about, like, is this very painful for the patient? I mean, obviously they're put out.
Exactly. Yeah, the patients are usually asleep during the implantation. When they wake up, there's usually a burning sensation that something has been put inside them, but it's rarely painful. They've done wonders with pain management now, so they can put the patient under general anesthesia for the procedure, and then they can treat it with local anesthesia immediately following, and then also administer pain meds as needed, so the patients don't complain too much about pain, and they can return to function within 24 hours a lot of times.
Wow.
after the surgery. And that's how you see football players or basketball players who have severe injuries getting back to the field so soon.
Yes.
Because they usually have surgery.
And of course, hospitals don't want to keep people. Oh, they won't. Not that they don't want to, but the insurance companies
That's right.
won't keep them.
Yeah, exactly. The cost of a patient staying over, and also the resources that are needed to care for that patient. They often want to get them out, and like I said, the patients can walk home 24 hours after surgery a lot of times.
Yes. And so do you have any idea, like how long these items might remain in the body, if not forever?
Yeah, so all of our implants are designed to stay in the body forever. We have to design them so that the patient will accept them forever, just in case the patient never goes back to the hospital to have them removed. That being said, a lot of times the surgeon will actually remove the implant from the patient anywhere between 2 or 4 or 6 months after the surgery, once the bone is fully healed. It's much more common in Europe to have the implants removed. In the U.S., a lot of times the patients don't want them removed because they don't want to go back under the knife, so to speak.
Yes. Yeah, maybe you could speak about a few of the other items.
Yeah, so I mentioned before that there were 3 ways to treat trauma. One, as I mentioned, was the plate. One was this nail or the rod. Another one is external fixation, which I only brought one component of with me. But the other way to treat a fracture is by actually building a frame outside of the patient. So this component is typically outside the patient, and it's connected with long pins that go through the skin and into the bone. So there'll be long pins which will go into the bone, come out the skin. This will be connected to the pins, and then there'll be a long rod which will connect to another construct. So this, for example, if there was a humerus fracture, a pin would go into the humerus as so,
Yes.
and then there would be another pin and clamp over here, and that would hold this fracture together. So external fixation is...
And that's outside the body.
Exactly.
And it remains there for how long it is.
Usually at least a couple of weeks, often a month, it'll be there. So sometimes you'll see people walking around with these frames built outside their body.
Really?
Yeah.
I wouldn't think that's a great way to do it.
Yeah, it's really common in war injuries because on the battlefield there's not much you can do to stabilize a fracture, so they'll have to place pins and connecting rods across the fracture site so they can really heal or at least initiate the alignment and the healing of the battle time fracture.
Yes.
To make sure that it can get started on the right foot. I also brought an interesting implant, and this is interesting because this is like a plate and a nail in one. Because you can see that it's very similar to a plate, and this is intended to go on the femur for a hip fracture, and this is a humerus bone, but you could kind of get the idea of how it lays on the femur. But
Yes.
then this portion is drilled into the head of the femur bone, and then this long aggressive screw is put into the hip itself. So if you can imagine, your hip bone has a nice ball. The femoral head
Yes.
has a big ball. And they'll actually put this aggressive screw into the ball of the femur, and then put this plate right over top of it, and then they'll fix it into the leg bone itself.
My God.
Yeah,
Wow, it's amazing.
it's pretty incredible, and it works very well. It has over a 99% success rate.
Oh,
with this.
excellent.
Yeah.
So maybe you could speak about some of the injuries that might require such instruments.
Lately, anything that's not a simple hairline fracture tends to get implants. Nowadays, surgeons are going towards the side of caution and promoting the use of implants early on. Mostly it's because of the return to work. So they've done cost studies that show that it's overall cheaper from an insurance side and also from a return to work side to actually get the surgery, get the implant fixed, and then get right back to work. So very common with spiral fractures of the long bones, obviously compound fractures of the long bones. So spiral fractures, as the name would suggest, is when you have a spiral-shaped fragment, usually when the bone is twisted into
Yes.
fracture. A compound fracture is when the bone is broken and actually exits the skin.
Yes.
And that's very commonplace for these implants to be used.
Oh.
We have specifically designed implants for almost all the long bones in the body. So everything from your fingers to your arms to your legs to your toes. Then we also have basic implants for the bones that are not long bones, your pelvis or your scapula or your ribs. We have non-specific implants for that, which can just be used
Sure.
to the surgeon's discretion.
Yes, and as far as, say, fingers, do you have such... Well, I wouldn't think this device, this tool, would be for like a finger. Do you have other different sizes?
We do, yeah. So typically for the fingers, we would not use a nail. We would use a plate. Obviously, this plate is certainly too big for the fingers.
Yes.
I think I didn't bring any plates for the fingers with me, but you can actually see on this skull, this plate right here is actually very similar to a plate that we have for the fingers. So you can see this little T-shaped plate here
Yes.
with the 1.8 millimeter screws. So those screws are only about 1/10 of an inch or so. So
Yes.
they're very very tiny screws, and you can see there. And that's most commonly for the fingers, at least the most common finger fracture that we get that plate is often called a boxer's fracture, and that's when you break the outside knuckle of your pinky. And it's obviously, as the name suggests, it's most common when people were punched something or someone, and then they'll break that because that you hit the knuckle first,
Yes.
and then you break the bone.
Wow. That's something. Well, Nick, how did you get involved in this area? I know you went to school. Like, what directed you into this area?
Yeah, so when I was in high school, I had a physics teacher who really showed me how exciting engineering was and the promise of engineering and the field of engineering and technology. So I knew when I was in high school that I wanted to be an engineer. And as I got further along in high school, and then as I went on to college, I saw that biomedical engineering was really a great way to help people and to change the world and to evolve society even more. And when I got out of school, I found Stryker and I found their trauma division, and I thought that was a good way to treat some acute injuries and really help people that might not have much else.
Definitely. Yeah, Nick, maybe you could talk a little about your view of technology and maybe about, maybe part of the population talks about God's will and you shouldn't mess with the body or, like creationism.
Yeah, I think that some of the arguments against technology or against innovation have some merit, but I think that in healthcare specifically, I think that merit is diminished. I think that when you talk about these implants having a powerful effect on the quality of life of people, I think it's hard to argue that we should not do everything in our power to help people. I think that the military is a great example. Everyone supports the troops and everyone really wants our troops to come home safely. I don't think that you're really following nature's path by allowing someone to be in pain and someone to heal incorrectly.
Yes.
I think that if you're helping people, you're fixing fractures, you're preventing deformities, you're alleviating pain. I think all of those things are reasons to pursue technology.
Exactly. And you had said that as these pieces or metal, that they're working on other materials for these implants.
Yeah, exactly. So nowadays, almost all of the implants that we make are manufactured from a titanium or titanium alloy, stainless steel, or cobalt chrome.
Yes.
Because of their demonstrated performance within the body and the fact that they're all either biocompatible or at least bioinert. But more and more implants are being manufactured from plastics as well. It's been common in the joint spaces, so in shoulders, hips, and knees, for plastics such as polyethylene to be used as bearing surfaces. So to ensure that it's a nice lubricated surface for the articulation of the joint. However, I think more and more polymers are being evaluated for use in the body. These polymers polyethylene would not break down within the body, but some polymers, such as polylactic acid or PLA, can actually be resorbed by the body. So over the course of time, the body will actually eat away the implant itself and resorb it and utilize the calcium and the lactic acid that's in there to actually rebuild the bone itself. And when the bone's healed, there's nothing left of the implant, and the implant has faded away.
Oh, wow.
Yeah.
Yeah, I would think in America that would be ideal. People don't like to sit and slow down. They like quick, fast.
That's right. Yeah, exactly.
Red light.
Right.
No red lights.
Right.
People,
And also, everyone's so scared to go back into surgery that this would be a good way for them to not have to go back into surgery.
yeah, exactly. So how far away are we from this being regular practice?
Yeah, so we're still many years away from that. I would say we're still. I would say by 2020 we can expect to have a lot more implants made of plastic.
Yes.
There's a few things that are limiting our progress here. First of all, just the chemistry of the whole thing. You have to design these polymers and test them extensively to make sure they're safe.
Sure.
But also the FDA approval process right now is not very streamlined, and it's also very prohibitive of innovation. And so the FDA doesn't really allow major leaps in innovation without significant clinical testing.
Sure.
And the costs associated with that clinical testing are often prohibitive of development by companies like mine until someone else gets on the market with it. So a brand new product can't really get through the FDA approval system very easily. You need to have a product you can reference to. And unfortunately, there just aren't many plastics that are being used currently to reference from.
Yes. So is your company, competition? I'm sure there's huge number of competitors.
Yeah, there's a lot of competitors. Our biggest competitor is Johnson & Johnson. So Stryker is based out of Michigan. Johnson & Johnson obviously is based out of New Brunswick, New Jersey. And they just acquired one of our largest competitors based out of Switzerland. And it was actually the largest medical device acquisition of all time. And so now Johnson & Johnson owns that company, and they're now number one in the trauma business. But they're also very high ranked in the joint replacement business as well, through their subsidiary in Indiana. So they're very large.
And this is Howard and Johnson?
Johnson & Johnson.
Johnson.
Yeah, the same company that makes Band-Aids.
Yes.
Things like that.
Yes. So maybe you could speak about costs.
Yeah, so the costs of these implants, so first of all, they all have to be very precisely manufactured with very tight tolerances, and also the materials have to be completely traceable and also have to be a high level of quality just in themselves for the material. So a lot of the cost of these devices comes from the materials and the quality systems that are put in place to ensure that they're going to be safe and effective for use in patients.
Are you telling me these implants have serial numbers?
Absolutely, yeah.
Do they?
Everything is lot controlled. So there is a number printed on here, which you can actually see. It's the very far right number there. And if you were to take that number and put it into the computer at Stryker, I could tell you what date the raw material was delivered to Stryker in Germany. This was made in Germany. What date that arrived, the raw material itself, just the brick of titanium, and then also where it came from, where the foundry was that it came from. It's all completely traceable, top to bottom.
But no barcodes.
No barcodes. There's barcodes on the packaging, so these all come in sterile packaging to be used in the patients, and there's barcodes on them which are scanned.
Yeah.
So you could even go to your doctor and say, I want to know the lot number of the implant that was put in me, all the way down to the small screws that go into these plates. They're all measured. They're all scanned. The doctor, the nurse, the hospital, the distributor, and the medical device company all know the entire traceability of the implant.
It's crazy.
It's pretty amazing.
Amazing, not crazy.
Yeah.
I didn't say that. It's amazing.
And you're talking about cost before. It's also important to highlight that that on average half of the cost of half of the price, I should say, of an implant is due to the regulatory process. So the fight, not the fight, the challenge that we have with our government to get these devices cleared costs so much money that companies like mine have to pass that on to the hospitals.
Yeah, is it possible, like other countries have different measuring tools to get approval?
Mm-hmm.
So you could maybe get some of these, like, approval in other countries.
Yeah, we're going through that right now with the project that I'm working on currently. So we are going to launch the product in Europe before we launch it in the U.S.
Yes.
Because it's already been approved in Europe for use, but it's not yet approved in the United States. So patients in Europe are going to be getting the newest and most innovative fracture treatment, but patients in the U.S. can't have it until the FDA has cleared it.
Really? I mean, I know with, like, stem cells that they're, as far as in the U.S., they really don't allow that. But you can travel,
Right.
maybe to Mexico and get stem cells there.
Right. Yeah, it's similar. So there's an entire tourist industry built on medical treatment and the different ways, different types of treatment that are available in different areas. Canada has its own health regulatory agency. Mexico does. Europe does. So it's not so much for the fracture business like what I work in, but with the joint replacements and especially with prosthetics, some of those components people will travel to have them put on.
Sure. Yeah, Nick, maybe we could speak about the recalling of implants. And maybe, like on TV, like Law and Order, they always have an episode about parts being recalled and fighting about that.
Yeah, so unfortunately, recalls are part of life with a company like mine, and we never like to issue a recall. But the process for a recall is basically whenever something out of the ordinary happens within the OR or during the patient's time with the implant, the surgeon is required to report that to my company or to the company that made the implant. And so each one of those reports has to be investigated by my company and must be submitted to the FDA with a reason about why it happened and why we don't expect it to be a threat. If enough of these reports are gathered, a company can voluntarily recall these parts. Stryker admittedly just had a voluntary recall of our Rejuvenate hip system. We said that we didn't think it was a safety issue, but that we wanted to bring the parts back in. So patients who already had the hip didn't need to have it removed. However, the ones that were in the hospitals, we asked to have those back. And so we had those shipped back, and we sent new replacement parts to the hospitals. There was also a famous recall recently from Johnson & Johnson. It was their ASR hip system. And that there's been a lot of commercials on. Lawyers will have commercials on TV. If you had a DePuy hip, which is owned by Johnson & Johnson, then call this number. And that system, they found that it was producing metal debris within the joint. And so Johnson & Johnson was forced by the FDA to issue a recall. And that recall was so extensive that they had to remove the hips from patients who already had the hips put in. So they had to put the patients back under the knife and actually extract the implant out and put a new implant in. And that led to several complications and unnecessary pain for the patient.
So even if the patient didn't want it, they had to do it.
Yeah. So with the exception of if a patient absolutely does not consent, then there's no way the surgeon could take it out.
Yeah.
But it was strongly encouraged by the surgeons and by the medical field in general that these be removed, because there had been overwhelming evidence that this debris was being formed and it was hazardous.
Oh boy.
Yeah.
So Nick, did you ever have aspirations to take this maybe and get involved in medical or doctor or what have you?
Yeah, definitely. I have a lot of interest in doing that. The more that I meet with orthopedic surgeons, the more I see that I'd really love to do that profession. And I've been working on doing some studying in my spare time to try and apply for the MCAT, which is the Medical College Admissions Test, and prepare myself to actually try to go into med school.
Really?
But it's a little late now for me. I'm 27, and so by the time that I was able to take the test, go to med school, graduate from med school, do a residency, and then have a fellowship, and then be a doctor, I would already be 35 or 40 years old. But that being said, it's not unprecedented, and I'm still considering it.
Oh,
I think it'll be great.
that's excellent.
Yeah.
That's awesome. That's very exciting.
Yeah.
So, that's good news. Yeah, maybe, Nick, you could tell us about the future of implants. You had mentioned about the degradable implant.
Yep.
Are there any other breakthroughs that are down the road?
Yeah, I think so. I mentioned plastics before. I think along with the biodegradable implants, or the resorbable implants as we call them, there's also several other frontiers for plastics that are on the horizon. For example, we have a device which has been approved by the FDA, which is made of plastic, and it doesn't resorb, but it actually dissolves inside the bone. So the surgeon will put this plastic pin into the bone, and then he can use ultrasound, just like how they look at a baby inside the womb. They can use ultrasound to actually melt and dissolve the plastic into the bone, so that the implant can't be removed. And then that plastic is fused into the bone forever. And then also there's several fields where collagen is starting to be used. So collagen is a naturally occurring polymer which is produced it's in our fat, it's in our cartilage, and we can use bovine collagen, so collagen from cows. We can extract it from the cow and then use it for different applications, whether it be to fill a void in a bone, so a fracture or a gap, or we can use it to actually construct new structures inside the body. I think collagen is another huge frontier. So I think that plastics and biologics are going to be the two big game changers for the medical device industry.
Exciting.
It's very exciting.
Yeah, so I had found out that Stryker was started by Homer Stryker many years ago.
That's right.
I believe he was born in the late 1800s, and the company has grown, and it's all around the world.
That's right.
So people interested maybe in looking into implants, what could they do?
Yeah, so Stryker.com, so STRYKER.com would be the first place to look. There's been a big marketing campaign recently for our knees. So we have a website dedicated to the Stryker knee. It's called GetAroundKnee.com. So it's Get a Round Knee, and that's because the shape of our knee is a circle.
Oh.
So that's the clever marketing trick there. It's our triathlon knee system. But Stryker's a great company, and we have divisions for every medical indication, really.
And so we're talking not just implants, but also other areas.
That's right. We make
Such
medical
as?
equipment. We make power drills. We make beds. We make stretchers. Any stretcher that you may have seen, it's the color yellow. Stryker actually has that trademark. So if you ever see a yellow stretcher, it's made by Stryker. We have overwhelming market share in stretchers.
Oh, that's fantastic. So I know before we end, I know you're a newlywed, and I want to congratulate you about your marriage.
Thank you.
And a shout out to your lovely wife, Courtney, and this great marriage and
Thank
great
you.
success with it.
Thanks, Dan.
Oh, my pleasure. So, in our last few minutes, is there anything you'd like to add?
Well, I would just like to add that the medical field is only going to get bigger from here, and it's growing significantly. And I think that it's nothing to be scared of. Surgery used to be something to be scared of, but now I think that it's really the best course of treatment for fractures and also for joint pain and for issues of joint. Obviously, you should discuss it with your doctor, but I would encourage anyone to look into something like that if they're interested.
That's great input. Well, Nicholas Morphing, note the name, Morphing. That's a great name. Thanks for joining me.
Thanks, Dan. It's a pleasure.
You're welcome. I'm Dialogues with Dan. Well, everyone, Nicholas Morphing. Have a good evening, everyone. Peace.
It's not just radio, it's Rockland World Radio. RocklandWorldRadio.com.